Bismillah ar-Rahman ar-Rahim. Today we are going to talk for the second lecture and we will start with each other for next title, which called parabola. Parabola is defined as a geometrical shape drawn by moving a point in the plane, provided that its distance from fixed point F, and we have to understand what it does mean. F is a focus of that parabola, is equal to the constant of a straight line called directrix. When we talk about something like that, so we have all the time one axis, maybe y axis or x axis, and we call it as a symmetry axis or axis of symmetry. Means that they will be similar to each other through both sides. If we have a vertex of that parabola, we have two distance. One is called focus of it, and the other one is a directrix. So both of them are indicating the parabola direction, and our curve will be something like that. So what we call about the symmetry, that the half of that curve exactly same like that side. So both sides exactly similar, and looks like that if we look mirror, so we'll see the same other sides like each other, even the distance. So what we have here, if we have that line crossing the focus and perpendicular on that axis, we call it lattice rectum, and we have that distance which all the time drawing that curve and giving me all the points of the intersection between that line and the perpendicular or the projector line on that directrix. If we will look at that figure, we will find that this curve, green one, is something like that point is start moving all through all the side, all the curve, to draw that curve. So if come to here, that means that vertex of that parabola, and this vertex start moving in that side to draw this curve, and to that side to draw this curve. Let us see how this is the focus, and this is the victim, and that the directrix. See the vertex going up and going down similar. Again, if we look at, we will find that midpoint between focus and directrix, and this is the vertex. Here is the vertex, but coming up here. So that line and the distance of it drawing that parabola. So that one moving up, and all the time this perpendicular on the directrix. To see more than that, so what we understand, that this distance when comes to here and intersect here, so it will give us the vertex of it. See how it draw that parabola. So the parabola is so many lines tangent to that parabola, so many lines coming and tangent that curve, so it gives me the parabola. In fact, two methods to draw that parabola, whether using the first one from that pathing one from the focus and taking the projection as perpendicular on the directrix. That first way to draw that curve. يعني عشان ترسم البارابولا ديت يا اما بتاخد الخط الواصل من نقطة الفوكس لغاية الفيرتكس وبتحركها بشرط ان دائما وابدا يكون عندي البروجيكشن بتاعي انترسكت هنا اهوت، ويكون البروجيكشن اللي هو الاسقاط رأسي على الدايركتريكس، او ان احنا بنبص على الطريقة التانية واللي هي بيكون فيها ان انا باخد التانجنت اللي موجود عندي ده. التانجنت الموجود عندي هو ان يكون عندي خط جاي برضو من الفوكس دوت، ودائما وابدا يكون عمودي معايا على التانجنت، وبالتالي بنقدر نجيب الموفينج بوينت along the line، طالع نازل. تعال نبص مع بعض اهو الموفينج بوينت، this moving point, this moving point like this. See this moving coming there and starting getting smaller and getting back again. Yeah. Right. What is the application of that? We can use it for making something like hanging bridge or supporting bridge like that, or making the communication dish. And we know all of us what is the communication dishes, or solar energy collector. So we can collect the sun energy over that one, or solar energy of that one, and getting here to the focus and use this energy for storage or for having electricity or whatever. So these four, and there are more information. Let us study that one and getting the value of the equation, because we are all engineering، يعني كلنا مهندسين. المهندس لازم يكون عنده حاجة اسمها معادلة، فلازم ولا بد أن يكون عندنا معادلة ندرس عليها هذا الكلام. General equation for the parabola. Suppose ان انا عندي B is located on the parabola curve, و F is the focus, و RQ is the directrix. So this B equal to the point FA, which is dimensions rectangle X equal minus A. Let's see what it does mean. احنا عندنا دلوقتي X and Y, and this is our parabola. So we have focus and we have directrix. This is the vertex of it. ده راس البارابولا، دي راس البارابولا. So لو عندنا الديستانس ديت بتديني directrix, so we should have the similar distance for the focus point, this one. Okay, so the distance coming from that point which along the curve to that point which is the focal, we call it BF, and BF, this one should be equal to that BN. If we have a projection on that X, so we'll have here perpendicular on the X. So BH is the distance between this focal and the perpendicular or projection of point on that X. The distance between that one to this one is X minus A. Why? Because this up to here is X, and this value is equal to that value, and this one is A. So it should be this X minus A. This distance is from starting from 0, so Y minus 0. Let's see how can we get the equation. Right now we have that focal and this BF and this one. So if we look, BN equal BF here, and this one is a right angle triangle with right angle, so we can apply Pythagoras theorem, which say that BF square equal to BH square plus FH square. So to get the value of each one, BH square, that this one is equal to y minus 0, so we put it here, so I will substitute that with that. The second one, FH it will be x minus a square, so our equation after substitution in equation 2, it will be BF square equal y minus 0 square plus x minus a square. So now we can see in another form that y square plus x square plus a square plus minus 2 xa ax give me f bf square. Okay, this is one, and to get the square root of that, so you have to get square root of that, so bf, just bf, will be square root for that equation. Question 6, we can get, if we look here, that we have this x and this one a and this one x minus a, whereas bf equal bn, that we talk about it before. احنا كنا عارفين ان بي اف بتساوي بي ان، واحنا وصلنا للبي اف. طب بي ان ما زالت مجهولة مش عارفينها، لكن بي ان احنا عارفينها ان هي بتساوي بي تي بلس تي ان، يعني بتساوي اكس بلس a. So من equation 6 and 7 in equation 1, so we'll get this one. This one coming from there, from here. See that BF equals that term, and I took it, I put it here, and Bn equal x plus a, I put it there. So if we square two ends, we square two ends and rearranging them, so we'll find this plus a square and this plus a square, and two are in different sides, so this one will be diminished with that one، لأن دي هتروح هناك بالسالب، فهيبقى a مع ال a square مع ال square، also x مع ال x, and this one will be positive, so it will be 4ax. This is the equation of that parabola curve. So the equation is so easy, but it has to have some condition. The condition that should be on the positive x, so y square will be having this form. In we have our parabola in the other side, in the opposite side, so this one will be negative. Okay, see, we are going to talk about that when we going to the characteristics of the parabolic equation. So the parabolic equation is a similar or symmetrical around x, whose f of x is to the right, and this is the most important thing, right. See, so this one is the most important thing. Once you are to the right, the directrix, so x plus a equal 0, and o we call it as vertex. let's see the parabola vertical focal hypotenuse. The line cuts the curved parabola through the focus vertically on the cutting axis. Let's see what does it mean. Now we have this point and our focus is there. We know that this one is A and this one also is A. So both of them are equal. And this line is coming from there to here, and this perpendicular on our x. Our pole, our original point is 0 and 0. So here is x 0 and 0, and this is the vertex. So our point here is vertex of that parabola, and this is our condition right now. So our equation here will be y square equal 4ax. Okay, let's see that a and that a and this l. This line from here to there equal from there to here. So b equal bn equal bf. A from here to there and other a from here to there. So this L will be 2 A's. Let's see what is called right now. BF equal BN. BF equal BN. So BF equal 2 A's. L equal 2 A's because BF equal BN. So BF is L. So L equal to A. So 2L smalls, which having the distance from there to there for both sides of the curve, so give me capital L. So capital L equal to 2L small or 4A's. So that line, lattice rectum, have this lattice rectum is equal to 4A. Okay. The possibilities for equation, parabola equation. First one, when we write for directrix, and that means x equal minus a or x plus a equals 0, and this our equation which we got it before. So here it should be the symmetric axis s x, or the parabola axis is x, and our focal is there, and our vertex is the original point, and the directrix in negative side but x in positive side. So our equation will be like that. So a equal greater than 0. Okay, let's see the second one. Here change the direction, left directrix. So we are in negative x. The other one, it was positive x. That means we are going this direction. The other one is we are going in the second, in the opposite a direction. So x minus a, because x is going negative and a is going positive in this side, so it will be y square but changing the negative because left side. So our axis is still the same. Our focus is here, still our vertex in the original, but a, the directrix coming in the other side. I don't care about the directrix more than I care about my axis in positive or negative direction. The third one, the cutting y axis. So I'm going here to cut axis. of y. So I change the axis. So our original point, our vertex point is the original, okay, and the cutting is y, and the focus above. هنا بقى above mean the directrix, so positive y. Let's see. Okay, this is focus here above, and this is the vertex still in the origin, and this is the directrix here, so comes back to positive, but the x and y interchange each other in the position, so x square here will be equal 4y ay. The final possibilities is similar a y, still y, but the focus lie below, not above, below the directrix, and in negative, so x is less than a less than 0, and it will be similar to the third one, but in negative 4. So our directrix down there, our directrix is above x, and vertex still the origin, and this one is the focus, and from here to there equal from here to there, and our equation is that, and this is symmetry axis is y. So we have four cases. One is the right and one is the left, and both of them y square equal 4x, but one is positive, the first one, and the second one is negative, and we have two other forms. One is up or above the directrix and one below the directrix, and both of them equal x squared 4ay. One positive when above and one negative when below. The chord of parabola, which that we have here, as we said before, that the distance between this one to this one is equal x plus a equal 0 here, and we have that equation of it because we are right to the left to the direction, and we have a vertical focal tendon, this one, which is called latus rectum. We know that L, this one, L equal to L small, which is this one and this one, and L small equal to A, so that one it will equal 4A, and we have it before like that, and we said that our f of A, this one, equal to A's, so AB all together 4A's per L, so the half of the length is 2A, and this one already proved before. So let's see first example. Now we have focal coordinate 5 and 0, so A is 5, Y is 0. We need equation for the directrix length of the vertical focal. Let's see. Parabola equation in that way. This is 5A. Okay, so our equations here equal this. So we will have x with 5, sorry, A with 5, and we will have y square equal to 20x. Directs equation a plus a, x plus a equals 0, so it will be x equal minus 5. And it's possibly that say, okay, if that a equal 5, so our directions it will be minus 5 because it should be in the other direction and equal exactly to this one. يعني بمعنى آخر لو ده نقطة الفوكس ودي 5 و0 يبقى معناها a و0، يبقى معنى كده هو إذا كانت دي a و0 لازم ولا بد لو كان عندنا احنا الخط ده y والبرابلة بتاعتنا طالعة بهذا الشكل والنقطة بتاعت الفوكال اللي هي على الاكس دي هي ديت، يبقى معنى كده لازم نكون على نفس الديستانس بالظبط ويجي الدايركتكس بتاعنا بهذا الشكل. يبقى معنى كده اذا كانت دي 5 يبقى لازم تبقى دي ماينس 5، وده طبيعي جدا. جنرال فوكال سيندروم اوف كورس احنا عندنا ال بتساوي 4a يعني تساوي 80. That's it. That's easy. لو خدنا اكزامبل تاني وقال لك الفوكس coordinates find the focus coordinates and the equation of directrix and the vertical focal length ضرب. طيب وعندنا الايكويشن ده هنا هو اتعطانا الايكويشن. طيب ده مين ده؟ ده المفروض 4a هنا. يبقى احنا هنيجي نقول السوليوشن بتاعنا الجنرال بتساوي كده. احنا عندنا الكونستانت ده 12 لازم يساوي الكلام ده. يبقى معنى كده لو بصينا عندنا دي بيساوي دي، ايوه، يبقى احنا عندنا ال 4a بيساوي 12 يبقى ال a هتساوي 3. جبنا كده ال a يبقى الفوكال كوردينيت 3 و0 equal a و0 صح كده. طيب وبعدين we have here directory equation. The directory equation x plus 3, so x equal 3 minus, and of course I can predict that from here a equals 3, so means directrix equal minus 3, and the tendo or the let's rectum then equal 4a, so it will be 12. Example 4, find the equation of the parabola whose cuts was 0 minus 4. See, now we indicate that the focus is down on y, so this is the fourth situation, fourth case we study. Each equation from the straight line y minus 4 over 3 to find the length of the vocal. حلو قوي. See, once we have this one, this is the distance. The parabola curve is located below x-axis with the distance y equal كذا from here, and the parabola equation in the image of or in the form x. This is the fourth case we studied, and now we have a equal 4 over 3, so when substitute in that equation, so it will be minus k. So this is our equation right now for the parabola. Equivalent parabola equation, it will be like that, and the latest it will be 4a will be 16. Finally, if we have in moving axis, if we going to move the axis, what does it mean moving axis? Suppose I'm having a new axis y dash and x dash, and I have my curve for the parabola, so I have the directrix here and this end, so I'm having here RQ my directrix, and I have new B which represent x dash y dash, and this is the focus of that parabola. All of this coming not on original Cartesian axis, but this our Cartesian axis. If we are going to talk about Cartesian axis, that means x and y. So we are away from x and y, and we have a new axis, x dash and y dash. So see, we are far away from y, from x with k, and far away from y with h. So we moved from x to k and from y to h. So now our original not 0 and 0 but h and k. So now here all that give me y, and all this give me x. Let's see, this is x dash and this is the y dash. So y is equal this and this, x equal this plus this. See, right now our equation in terms of the all the coordinates, which y dash and x dash, so it will be this one to the right of the directrix. So this case 1, y dash square equal 4a and positive because x is positive. So now we want to change from y dash to y. To have this, that means y dash is equal y minus k, and x will be x dash will be x minus h. So suppose putting this, so to remove that one and back again to the original one, you have to apply in this equation. Possibly we can have 4 cases. I need from you to predict the rest of the cases. انا عايزك تعمل prediction للثلاث حالات التانيين، ان احنا دي المعادلة في حالة لما يكون على اتجاه اليمين، لا انا عايزك تجيبها لي على اتجاه الشمال واسفل واعلى الدايركتريكس. So you have to integrate that or to predict that, and you have your BDF materials, and go and try it with yourself, and I need you to give me your prediction on the classroom, please, on the classroom in time, I mean next week, Thursday next week. You have to give me the prediction for the other 3 cases. Okay, let's see last thing what will be that's what we talk about. All that things we have it before, and just I need to give you something for that thing, that when that one on the other side and up and down. Okay, finally, if we have example coordinate, we need the coordinate of vertex, focus, and that tendo or called focal length equation, and we need equation for both direction, directrix and axis of the polar. We have this equation. For example, this equation, of course, not a real form of parabola, so we need to change this one to the real parabola curve equation. Equation represents an x equivalent axis completing a square both of them. هنعمل عملية تقسيم بسيطة، ان انا هاخد الواي سكوير مع الماينس 6 نكسر ديت وناخد منها 9 وهيتبقى لي 8 بلس 8 اكس. هنعمل عملية اكمال مربع وهنجمع ناخد common factor minus أو negative 8 outside. It will be like that, and our equation now it will be similar exactly for that. So that means h equal 1 and k equal 3, and this one is 4a. The vertex it will be 3 1 or h minus 1, and I have right now h minus 1 and 3, and when we complete a equal negative 8, so a will be negative 8 over 2 negative 2, so our original 1 minus and 0, the length will be 8, the original will be minus 3 and 3, and the equation will be 3 y equals 3, x directly equal 1. Parabola equation, polar, just for reminding that if we have that 1, so we have r a plus r square cosine, so finally that we have L over 2 and L of r equal 1 minus cosine, so this one will be r and theta, and it will be L over r equal 1 minus cosine theta. That our session for this. I know that it was long, but it's easy, so please try to figure out the 3 conditions and give me your feedback on the classroom, and I thank you, and we will have 3 more lectures, and that will be the end of our session today, and thank you for your attention.